Hello everyone. In this video, I will explain my solution for a backtracking problem. Mm, this problem is we are given a set of 5 numbers, each between 1 and 10, and the target number n is between 1 and 100. So what we do is we must use all 5 numbers exactly once, and the operations plus, minus, multiply, divide, and the power to form an expression that equals to the total number n. So let's go over to the coding part. So the main idea is to treat this as a search problem over all the possible expressions. Initially, the list has 5 input numbers. So at each step, I choose 2 numbers from this list and combine them with one operator. So that gives me a new number which replaces the 2 old numbers. And so the list size goes down by 1. So I repeat this until only one number is left. If that final number equals the target, then the sequence of operations I used forms a valid expression. To implement this, I used backtracking as well as recursion. So for the recursion part, each recursive call solves a small instance with fewer numbers. As also for the backtracking part, if a particular combination of operations does not lead to the target, I go back, or maybe I backtrack to the previous state and then try a different pair of numbers on a different operator. So in this way, all the operations work, and if there's a compare and when I compare each expression or each result with the total number, if there's a total number, if the total number is found, or if it's equal, then I return it. If all the paths are exhausted and I don't find it, and don't find the proper, and if my result doesn't match with the total number, then in that case there is no match found. So because the problem asks not only the numeric answer but also the actual expression, so I store both the numeric value and the string for the expression. So as you can see, the numbers are here, and when I try to get this call the function, what I do is send the numbers and also a float of the target. It's like here. So what happens here is I get the value at first, like I have appended here. So possible values is empty, so I have appended a value plus b value, right? Because this is the plus part, so addition part. So I have added here, and in the second parameter, the value is the first value plus the second value. It is kept as a string. Similarly, in the negative part, I have tried both sides, like first value minus second value, or second values minus first value, because the minus and the minus part has two operations. And also I have added this similarly added the similar expression here. Similarly, I have done the same thing in the multiplication part, also the division part, and the power part. Okay, so what I have here is this is the core function where the uh, problem enters the find solution part. So this converts the input list, like 1 2 3 4 5, kind of 5 numbers inputs, into pairs, like how the pairs are like the first one is float, so numbers. So it's like 8.0. If the first number is 8, then the first pair is 8.0 comma and a string called 8. Or if the number is 9, then the first value is 9.0, and the second is a string called 9, and so on. And then it calls the recursive solver, which is this one. Mm, so the main working part is done in solve nums float target part. So the best case is if there is only one number left, then we check if the total, if it is if it compare equals to the total number or not. If it compares to the total number, then the total number is sent back. The expression is sent back. Else, nothing is. So it's else none is returned. Um, so the recursive. This is the base case, and for the recursive case, when there is more than one number, in that case, I try every unordered pair of indices I and j. Like here, I have done it here. Uh, then I build a list called rest, containing all the other numbers except the ones that are at position I and j. Next, I create all the possible ways to combine these two numbers using the allowed operators like addition, subtraction, and others. So I append each of them to the possible values array, and add them and remove them according to the values and according to the total number that they match to. So the for each candidate result of possible values, I create a new list of numbers consisting of the rest plus this combined result. So this happens in every recursive call. So calling solve recursively reduces the problem from n numbers to n minus 1 numbers, because every time the value reduces, right? So if any recursive call returns a non like a value except by none, then I immediately return it all the way back up, which means the algorithm has found a complete expression that equals the target. So if all pairs and all operations operate, if all operators are tried and none of them gives a solution, the function returns none, and the previous label will then try some other options. So it backtracks to the previous part. So let's go over to the sample executions. So I have executed 3 times. So for 84, so as you can see, I have written here sent finds. I have called find solution and have your numbers and the target number, and similarly these two. And while running this, we can see the value has come up like this, and this. So yes, this is the part, and as you can see, the explanation is everything that I have already told earlier. The code is actually the proper explanation of this algorithm. The pseudocode is written as per the script or the codes above, and we have generated approximate time and space complexity. It is actually quite hard to get time complexity in this case, but I tried to gain from experience. We'll have to verify this though. And the space complexity is not that much. It's in exponential, so it's k square. So this sums up the problem of this kind of game using algorithm. Thank you.